All right, 2010, number 3. This is a vector problem. Looks like we have a particle moving along a curve. Its position is given by this function, and the y position is not explicitly given. X and y are measured in meters, t is measured in seconds, and we do know dy dt. So we know the y velocity, we just don't know what y of t is. Of course, that would be the antiderivative of this. All right, so let's find the speed of the particle at 3 seconds. Well, remember that speed is equal to the square root of dx dt squared plus dy dt squared. So, and looking ahead actually to number or part B, find the total distance traveled by the particle. I'm going to go ahead and put in a speed function because I'm going to need it in a minute anyway. So, in other words, I'm going to go, and you wouldn't have to do it this way, but I think it's going to save me a little time if I realize that here, let's see, dx dt would be 2t minus 4, right? So we want the square root of 2t minus 4 squared minus x, or t, whatever, e to the x minus 3. That closes my power, that closes that, squared, and then that closes the square root sign. Right? And whoops, that should be plus, right? I'm solving, it's basically like a Pythagorean theorem solved for a hypotenuse. It should be that squared plus that squared. All right, and then I want to go ahead and I just want to plug in. I have my table in the mode where you can just type a number in. So I'm just going to type 3 in there, and that's going to give me my speed, 3.601. You can get that from the graph too. 606, sorry. You need to write this step out, or you will not get the full amount of points. Part B, find the total distance traveled between 0 and 4 seconds. Well, now that I have this in here, I can just go, ooh, I shouldn't have done that because I don't know what crazy window that is. So let me stop that, go back to the window, and go from 0 to 4. I don't really care what the y min and y max are. So it's off the screen, but it doesn't really matter. I just want to find the area under it. And then I can go second calculate number 7. You could do this all on the home screen, right, with the fnint function, but this works too. 0 to 4. Should start shading that in a minute. It's a little slow because it's a messy function. 12.937. 12.937.
Daniel Ferguson, please report to the main office.
That was the integral from 0 to 4, the square root of dx dt squared plus dy dt squared. And it's okay to call them this, right? But you do have to write out what you're doing. C. Find the time between 0 and 4 when the tangent line to the path of the particle is horizontal. Is the direction of the motion of the particle toward the left or toward the right at that time, and give a reason for your answer. So we want to know when the tangent line is horizontal. Well, the tangent line, the slope, is dy dt over dx dt, right? We want to know when that's 0, and that's 0 when dy dt is equal to 0, right? So let's graph that. let's go ahead and turn this off just in case I need that later. I'm going to leave that there. And let's graph x, graphing dy dt, x times e to the x minus 3. Is that what it is? Oh, minus 1. Oh, dear. Oh, no. Did I forget that before? Oops. Hold on. That means I think everything that I've done, all my answers are wrong. Shall we go back and fix them real quick? Let's see. Well, let me just, so I don't forget to do it again. Put the minus 1 there. All right, so let's see. That means in here I should have had a minus 1. Right? And so then when I went to my table and typed in 3, it would have given me 2.828. And then when I did my graph, oh, it's doing the graph of both of those. Oops. And I just want the graph under this one. Well, let's see. I need to do second calc. I want to do the integral under, yep, that's the right function. So from 0 to 4. So that's not going to be right there. So that should be 11.588. Right? And actually, they gave us meters and seconds in this, so while we're going back and correcting things, the speed should be in meters per second, right? And then this is the total distance traveled, so that would be in meters, right? And then, okay, so back to here. Now, let's go back to y equals, turn that off, and go ahead and graph that again. We're trying to figure out where dy dt, which is this, equals 0. So second calculate 0 of that. And that happens at t equals 2.208. Okay? So that's the first part of that. And now they want to know, is the direction of the motion of the particle toward the left or toward the right? So let's see, what's dx dt? That's the horizontal motion, right? At 2.208. That's equal to, the derivative was just 2t minus 4, right? So 2 times that minus 4. And I can see that that's going to be positive. That's all we really care about. So let's just say that. It's greater than 0, right? Because that's 2 times that is bigger than 4 minus 4. So dx dt is greater than 0. So moving to the right, because that's the positive direction. All right. And last part. There is a point with x-coordinate 5 through which the particle passes twice. Find each of the following: the two values of t when that occurs, and the slopes of the lines tangent to the particle's path at that point, and the y-coordinate of that point, given that y of 2 is equal to 3 plus 1 over e. All right, let's take those one at a time. So first of all, there are two values where that occurs when the x-coordinate is 5. Well, here's the equation for the x-coordinate. So we're talking about t squared minus 4t plus 8 equals 5. Let me do this on my big sheet here. So for part D, number 1, we're setting the t squared minus 4t plus 8 equal to 5. And that gives me t squared minus 4t plus, so you could graph this, of course, because you have your calculator, but so t is equal to 1 and 3, right? Part 2, we want to find the slopes of the lines tangent to the particle's path at that point. Well, that's dy dt over dx dt. So that's dy dt over dx dt, well, evaluated at t equals 1, and that's equal to the dy dt is 1 times the e to the dy dt. So it would be it would be e to the minus 2 minus 1, e to the negative 2 minus 1. That's what you get when you plug 1 into that. I can just leave it like that. And then dx dt is 2t minus 4 over negative 2. And then the slope dy dt over dx dt at t equals 3 is equal to dy dt is equal to, that would be, when I plug in 3 here, it's 3 times e to the 0, so that's 3 minus 1, that's 2, over, plug in 3 in here, that's 6 minus 4 is also 2. So that's just equal to 1. So the slopes are e to the negative 2 minus 1 over negative 2 and 1. And last, what is the y-coordinate of that point given that y of 2 equals 3 plus 1 over e? And that, since I have the derivative and are giving me a point, this is like a fundamental theorem kind of problem. I want the y-coordinate of that point, which has an x-coordinate of 5, and a y-coordinate of, I guess I need to plug either one of these t's into the so we could use either one of these times, right? We know that either one of these at these times, we know that that's what we're looking for. So in other words, you can set up here, you can set up your fundamental theorem integral. You can do the integral from 1 to 2, or you could do the integral from 2 to 3, because those are the two, at those two times it's at the same point. So they're both going to give you the same y-coordinate. Maybe I'll do both for you real quick just to show you that you get the same thing. Of dy dt, so the integral from there to there, dy dt, that's equal to y of 2 minus y of 1. Right? And I know that this is 3 plus 1 over e. So here I would get y1, which is what I'm looking for, the y-coordinate at that time, or that time, is equal to 3 plus 1 over e minus the integral from 1 to 2 of t e to the t minus 3 minus 1 dt. So I just need to find that. From 1 to 2, do I have that thing graphed? I do. So that's the only one turned on right now. So let's just use, since I already have it graphed, I want the area under that from 1 to 2. So integral from 1 to 2, it's negative, it's minus that integral, so it looks like I have 3 plus 1 over e plus 0.632, and that's equal to 3 plus 1 over, over e plus 0.632 is, oh, that looks like 4, doesn't it? I guess this was some version of some kind of e thing, but I'm going to say that that's 4. 4. You could say 0.000 just to be sure, but I bet it came out to be exactly 4. And then you could also have done, well, I'll let you try it, with the with 2 going from 2 to 3 and see what happens if you do that. And you'll get the same kind of thing. All right.